Hello. This is an example of optimization, and I will give you an interesting problem. This is, you have a strip of paper. Look at this. This is a strip of paper. Okay, it's not too wide. It's just here I have just a 5 cm. From here to here. From here to here is just 5 cm. So what is the problem? The problem is that you fold it. Okay, you fold it. And you find how long is this fold line. So you take a ruler and measure it. Okay, how long is this? And you change the way of folding it. Maybe you can do it this way. Okay, I need to mention that when you fold it, this corner should touch this line. Okay, all right, you fold it, you measure this side, and you change the way you fold it. Say, for example, like this, and the line becomes longer, right? And you measure it again, and you change it again, and you can have a much longer this line. Okay, so this, you fold it, and you try many ways. What is the minimum length of this fold? So you can find how you fold it, and how you fold it like this, or something like this, or even do this way. Okay, yeah. So what is the minimum length of this fold line? So this is our problem. All right, so let's make a diagram. So this is a strip of paper. And you fold it. Say, let's see now. So I call this X. And I lift this corner up and let this corner touch this edge. So when you do that, you will see that this side becomes this, so this is also X, right? You fold it. You fold it. This is X. And this is 90 degrees, so this side is 90 degrees here. 90 degrees. And where is the fold line? The fold line is this. So I want to find the expression of this line, and I want to minimize it. Okay, let's call this line L. Okay. So if this is L, this is X, and of course this corner is 90 degrees, then how long is this side? This side is square root hypotenuse square minus this X squared. Let's call this the width, the A. From this corner to this corner, it is A. Now, A is a given number, okay? And in my case, in my example, I showed you my strip. My A is 5 centimeters. All right. So this is A, this is X. So what is this? This side is A minus X. This is A minus X. And this is X. So how long is this side? It's a right triangle, so this side is X squared minus this square. Okay, this side is this. Look, you fold this triangle to here. These two triangles are identical. Therefore, this side is the same side as this side. So this side is L squared minus X squared. Okay. Now this is A. So if I draw a dotted line here, this is also A. And this is right angle. So how long is this side? It's this squared minus this squared. So this squared is L squared minus X squared. L squared minus X squared. And this is this square minus A squared. Take square root. So this side is this much. This side we already shown it's this. But look, this plus this is equal to this. So this is my equation. Okay. This plus this. Plus this should equal to this side. Good. Now I have L, X, A, but A is a given number. In my case, in my example, I use 5 cm. So this is my relation. I hope I can do something to find some unknowns. Okay. But I have square roots. So to get rid of the square roots, I need to square both sides. Square left side and square right side. Square left side is A plus B, so A squared plus B squared plus 2AB. So A squared plus 2AB A and B. B is also a square root. A squared plus 2AB plus B squared. B squared. So the square root is gone. A squared plus 2AB plus B squared equals the square of the right-hand side. Okay. From this, I can already see that the left side I have L squared, the right side I have L squared, so L squared cancels L squared. I have a minus X squared here. On the right-hand side, I have also minus X squared here. So minus X squared cancels minus X squared. So now my right-hand side is 0. So let's rewrite the left-hand side. Minus A squared plus 2 times the 2 square roots multiplied together. Okay. I must be very careful because it's so long. A small mistake will destroy everything. Okay, be careful. Be careful. Plus X squared. Minus A bracket square equal to 0. Yeah, equal to 0. Okay. Let's see now. I still have 2 square roots here, So I need to get rid of this. To get rid of these two square roots, I need to square it. But I have something here, so I need to move everything, this one to the other side. Leave this on the left-hand side. So I have 2 L square minus x square minus a square, another square root, x square. Maybe I should expand this, right? Okay, a square. Okay, just like what I said, I need to be very careful. A minus x square is a square minus 2ab, but I have a minus here, so I have a plus 2ax. And the last term here is b squared. B squared is x squared, but I have a minus sign here, so I have a minus x squared. Okay, I hope there is no mistake. Okay. All right, and then I should move this to the right-hand side, so I have a squared. Move this to the right-hand side, minus x squared. And let's see, I have this, right? Minus a minus x bracket square. Okay. Oops, no. So that's why I need to be very careful. Move this to the right-hand side, is no longer minus, it's plus. Very careful, very careful. Okay. A small mistake makes everything wrong. Okay, 2. Let's just see this. Okay, so 2. Just copy this. And now the right-hand side. Okay, a square, be careful, minus x square plus. Okay, I want to expand this perfect square. So a square minus 2ax plus x squared. Okay. I see that I have a minus x squared. I have a plus x squared, so they cancel. I have a squared plus a squared, so I have 2a squared. I have 2a squared, 2a squared minus 2ax. And this part is still the same, so I just do this, it's the same. Now you see, I have 2 here, and 2 here, 2 here. So if you divide everything by 2, the 2 is gone. So I have this now. Divide by 2. So 2 is gone. Oh, wait. Okay, here. I just noticed that I can simplify this. X squared here minus x squared here. So x squared is gone. So I have x minus a squared plus 2ax. Let me write plus first. So it's 2ax minus a squared. All right. And this is equal to, remember 2 is gone. So I have a squared minus ax. Now, I want to get rid of the square root here. So again, I need to take a square on the left-hand side and take another square on the right-hand side. So let's do that. Square of this, the square root is gone. Okay, the square root is gone. Now square the right-hand side. Okay, again, I must be very careful. A square of this, a to the power 4, minus 2ab, minus 2ab, this times that. So I have a cubed x minus 2ab plus b squared. Then I need to simplify further. To do that, I need to expand this. Okay. Again, this is a long work, and I need to be very, very careful. So this times that, 2a l square x. This times that, minus l square a square. This times that, it's minus 2a and x cubed. And this times that, minus minus is plus, so a square x squared. Now finally, this times that is minus 2a cubed x. And this times that, minus minus is plus a to the power 4. And then this is equal to the right-hand side. So I just copy the right-hand side. Okay, let's see. First of all, I see that on the left-hand side, I have a to the power 4, and on the right-hand side, I have a to the power 4, so I can cancel that. And how about a square x squared? A square x squared, the left side, and the right side, the same thing, left side and right side, I can cancel. And, oh, the left-hand side, I have minus 2a cubed x, and on the right-hand side, I also have minus 2a cubed x. So this term cancels that term. So the right-hand side is 0 now. So I have this now. 2a l square x minus l square a square minus 2ax cubed equals 0. Let me factor out L squared. I just want to check whether this is within the view. Yes, it is still within the view. So 2ax minus a squared let me move this to the right-hand side. Now, I need a new page. So, okay, let me check. Is that all right in the view? In the okay. So I solve for L squared. So this is the answer for L squared. I noticed I have a here, a here, a here, so I can factor the a at the bottom. When I factor the a at the bottom, the a at the top and a at the bottom can cancel, so I don't need to write a anymore. So at the bottom, After I factor out a and cancel a, I have 2x minus a. So this is what I have. Now I cannot simplify any further. Remember, L is the length of this full line. And I want this to be minimum length. So how do I do that? And you remember in calculus, if you want something to be minimum, you do the derivative. So I need the derivative of L and let it be 0. But if the derivative of L is 0, then the derivative of L squared is also 0. So you don't need to take, you do not need to write L is equal to the square root of this, and then do the derivative, and then let it be 0. It will be too long. So a shorter way is do the derivative of L squared and let it be 0. So the condition is L squared, the derivative should be 0. Okay, you don't need to take square root of that. Okay. So what is L squared, the derivative? The derivative of L squared. So the derivative of L squared is quotient rule. This is u divided by v. So the quotient rule says u prime v minus v prime u divided by v squared. So u prime is the top derivative. 2 times 3 is 6. 6x squared. This is u prime times v minus v prime times u. V prime is the derivative of this, which is just 2. This is v prime times u divided by v squared. All right. Okay, this has to be 0 now. Okay, this has to be 0. Because this is 0, so I don't need to consider the denominator. So what I have is, I don't need to continue the equal sign. I just let the numerator be 0. So 12x cubed minus 6ax squared minus 4 wait a minute. Yeah, that's right. 4x cubed equals 0. Now I have 12x cubed minus 4x cubed is 8x cubed minus 6ax squared is equal to 0. I factor out a 2. I factor out x squared. So I have 4x minus 3a equals 0. So for this to be true, I can conclude either x is 0 or this bracket is 0. But x is 0 means that is not the case. X is 0, that means this x is this part. X is 0, you don't fold it. You don't fold it, you don't have the game, right? You don't have the question, you have to fold it. So this is not 0, according to our question, which is never 0. So the 0 is this bracket. 4x minus 3a is 0. Then quickly I have x is 3a over 4. Once I have x, I can find L. This x will make the L minimum. So I substitute the x into L. The value of L will be the minimum length. Okay, let's do that. So I have L squared is equal to 2x cubed over 2x minus a. Now I have 2x cubed over 2 times x minus a. So what is this? Let's continue doing this. 2 times, the cube of 3 is 27. A cubed. What is the cube of 4? It's 64. 2 times this. But I notice that 2 and 4 can be cancelled. So I mean can be reduced. So it's 3a over 2 minus a. So let's continue here. 2 and 64 can be reduced. It becomes 32. So I have 27a over 32 divided by, let's do this. A can be written as 2a over 2. So I have 2, common denominator is 2, then the numerator is 3a minus 2a is just a. Then, so the result is a over 2. Oh, I forgot the cube. So this is equal to 27a cubed over 32. Divide by this is multiply. I flip the denominator is 2 over a. A cubed and a can be reduced to a square. So I have 27a squared. And 2 and 32 reduced is 16. So this is my L squared. Therefore, L is the square root of this. So when you take square root, you need plus minus. But according to this question, minus makes no sense. The length of the line of the fold cannot be negative, so you only take positive answer. So square root 27, if you do mental calculation, it's 3 root 3. This is square root of 27. Square root of a squared is just a. Square root of 16 is 4. So this is your answer. This is your minimum fold. So this occurs at, the minimum occurs at, the minimum L occurs at x equals, what is that? X equals 3a over 4. So my case, I have a equals 5 cm. So I should use x is equal to 3 times 5 divided by 4. And I should use a calculator to find it. It's 3.75 cm. And under this condition, the minimum length L is 3 root 3 times 5 divided by 4. and use a calculator, I get 6.5 cm. So this is the answer to this question. And I have the example here. I fold it. I use 3.75, so I need 3.75. So it's 1, 2, 3, 3.75. It's this marker. Okay, I tried it. So I fold it, and I make this corner touch this line, and I fold it. So this is my fold line, and I measure my fold line, how long it is. I expect to have 6.5. So let me see that. Can you see it? Let me take away this. So this is 6.5. You see, roughly, of course, my skill is not so exact, so 6.5. So this is the problem, and it's quite interesting, and it's long. It takes great care. You should take great care so that there are so many steps you avoid making any small mistakes. Otherwise, the answer is far off. So that's it. That's it. See you next time. Goodbye.